All right, everyone, welcome. Hello, my name is Dan George. I'm chair of the planning committee, and you're now in the keynote presentation, which we're very excited for today. A couple of housekeeping items before we get started. First, you all know, probably need to mute. Second, be cognizant of what you're displaying on your video. And the third, here's the biggest piece. This is a webinar session, so there is a Q&A and a chat. But be sure to use the Q&A to ask any questions that we can have Hilary answer in the end. And be sure to upvote the questions that you like. So we will start with those first. And without further delay, she is the co-founder of Hidden Door, the founder of Fast Forward Labs, the former chief data scientist at Bitly, and the data scientist in residence at Excel Partners. It's my pleasure to welcome a fellow data enthusiast, Hilary Mason. Hilary, welcome. Go ahead, take it away.
Thank you, Dan. Thank you so much. Hi, everybody. I'm super excited to be here sharing a topic that I'm really passionate and excited about with all of you today. And so let's jump into it. I'm going to talk about narrative algorithms, and I will explain what I think that means. And I know I'm going to talk for about 40 minutes. We'll have time for Q&A at the end. And if you have questions we don't get to, or you're feeling a little shy, feel free to ping me on Twitter at hmason or via email. So first, my own housekeeping slide. Just wanted to say thank you for spending this time. Would usually say, good late morning to everyone. We're sort of in the same time zone, but instead I'll say hello everyone, because who knows where you all are. It would have been a lot more fun to be together physically in Nashville, but I think we can all still feel the warmth of this community through the virtual screen. So I'm joining today from my home office in Brooklyn, New York, and I really am happy to be talking here. And I hope everyone has a coffee or a snack or your favorite hot tea, cold juice, whatever it is, makes you feel comfortable and interested in hearing about nerdy things. So why narrative algorithms? When I spoke with Dan and the other organizers about what good topics might be, they said, oh, we really want to explore something a little bit deeply and maybe something pretty technical that people can actually take back to their own work. And I thought about it, and there are several topics that came to mind, but this is the one that I've been obsessed with for the last year, and I'll explain why. Narrative algorithms are algorithms for interpreting data and expressing it through words, for interpreting language and modeling it as data. And, some people are very comfortable looking at columns of numbers. I'm sure we have many of you on this presentation right now. Some people are more comfortable looking at a visualization, which is a compression of that data into a representation that we're able to make sense of. And many people are more comfortable seeing something interpreted in language. And so like the sentence you see here on the slide, that has done the work of analyzing the data, visualizing the data, coming up with the insight or the conclusion, and expressing it in language that we can all understand. And even though I am a data scientist and a machine learning scientist by background, there are plenty of times when I am happy with that interpretation and don't actually need to see or am incapable of looking at a data set if it's of a sufficient size to necessarily draw my own conclusions. So I think narrative algorithms are potentially transformative because they allow us to interface with machines using the same interfaces that we use to talk to each other as human beings. That also gives our computational systems the ability to plug in to other human communication and to use language as a tool to augment and enhance processes that we're already running in an automated way. And so this is the general family of things I want to discuss. In order to really get into it, though, we have to understand where we came from. So I'm going to give you a very brief conceptual history of natural language processing. And by very brief, I mean about 5 minutes, because we only have about 40 minutes in total. And then conceptual, I mean more or less I'd love for you to understand the frame of mind and the philosophy of work at the time we're talking about, but not necessarily all of the details. A lot of this stuff is actually really interesting, and hopefully you'll be inspired to go Google it and read about it. And there are many Wikipedia rabbit holes you can go down. Lest you think, what did I sign up for? I didn't think I was going to spend my hour getting a lecture about NLP history. It is actually really funny, so bear with me. There's a lot of good stuff in here. And let's talk about the beginning. So in the beginning, natural language processing actually has its origins back in the 1930s-ish, where there were actually a couple of patents on systems to do automated machine translation. That is, take a document that may be in another language, such as German, and print out what it says in English. Most of those systems were coming from the philosophical underpinnings of an idea that language could be complete. So there were projects in the earlier centuries to actually try to write down a complete dictionary of the English language. I think today we know that that's a bit of a folly, especially the way language evolves and drifts. But at the time, it was not considered a folly. Most of the translational systems work similarly. So some sort of global lookup table, in goes one language, out goes another. None of them ever worked, but that was sort of the beginning. And why is it important to know these things? Well, because there's always a reason why things are the way they are. And so I saw on Facebook, one of my friends was just aghast that her son didn't realize that the save icon actually comes from a hardware diskette. I think many of us here today are actually old enough to remember using those things. But then she shared that she was shocked to learn that the phrases uppercase and lowercase come from a movable type printing press, where the larger capital letters were in the top part of the case, as you see in this picture, and the lowercase letters, the small ones, were in the bottom part of the case. And so, this was sort of her parallel of, she never had to do typesetting this way. And so there are always things where they are the way they are for a reason that made sense at the time. And we carry those legacies of language, of choice, of design forward with us. And especially in language technology, there are many of these things. So it's always worth spending the time to think about where we came from. And at first, it was all rules. And in fact, this rules-based dictionary approach persisted up into the 50s and 60s. And perhaps the most famous example of this is a bot called Eliza. And Eliza was a psychotherapist. And here, this system from Joseph Weizenbaum, which he built sometime between 64 and 66, was essentially just a few grammatical rules that would flip the sentences around. So if you said, I'm presenting a talk, it would sort of flip things back at you. It was not intelligent, but was symbolic, and was a fairly impressive demonstration for the time, but still all rules based. And so what came next? Well, before that, in 1950, Alan Turing proposed the Turing test, which you've probably heard a lot about if you were thinking about this stuff a decade ago. I particularly love this XKCD cartoon, which is saying that, like, this is the extra credit. In the Turing test, you have a setup where you have a computer, a human being, and an examiner who can talk to both of them, typically through a keyboard, but can't see them, doesn't know who's a machine or who's a human. And the goal in the Turing test is to fool the examiner into thinking the machine is a human. And it's interesting because this is by no means a perfect test of intelligence, but it's one where you have to show that you're at least as intelligent as the other human in the box. And so here the joke is, of course, let's try and fool the examiner into thinking he's a computer. And you might think this is just a joke, but this actually has happened. So this is a bit of a transcript from the late 90s, around 2000, 99, 2000, where this guy was on AIM, so AOL Instant Messenger, for those of you old enough to remember that, and his username got put on a list of bots, and most of the bots at the time were still Eliza-like. They were rules-based. They might have some cleverly pre-programmed responses. But he would get into these conversations where he could not convince people he was a human. And he would try really hard. Here he says, test me if you want. And the person says, well, why do you like music? And he's like, oh, I've never considered that. And they're like, oh, you're just a bot. And this is all online. And I'm sharing this because currently there's a bit of we're stepping away from the Turing test, which we'll come back to in a minute. All right, so in the 90s, things changed dramatically. For people who were working in this space, we've rebranded from artificial intelligence to machine learning and adopted probability and primarily statistical approaches. And if you want to think about this, again, conceptually, the idea is that we went from deterministic rules-based and expert systems where you had if-then constructions into a world where we started to be able to use techniques like naive Bayes, where Bayes rule became dominant, where support vector machines were useful, where we were able to start to do probabilistic calculations versus just rules-based systems. And this opened up a whole world. And there were other reasons for the rebranding as machine learning, such as the lack of funding for AI because people overpromised and underdelivered. But this was truly transformative. And there was an era in the late 90s, early 2000s, where people were trying all kinds of things, like neural networks became a big fad at the time. And we'll come back to that in just a moment. Yeah, I love the 90s. So for all the 90s kids in the room, this was really when the foundation of the work we're seeing pay off today was laid. Now, pretty much everyone who was working in machine learning in the 90s did go through that neural network phase, but typically gave up because it didn't actually work very well. But this is when we started to see things actually start to work in the wild. So you'll notice that if you were using ATM machines at the time, you could all of a sudden have an algorithm that could recognize the amount of money on your check. And also the routing numbers and such automatically. That was one of the first uses of computer vision in the wild, only possible because of these statistical approaches. You also saw a bunch of things like spam filters start to become first needed and second functional. And I still think they're one of the machine learning applications we all take for granted every day, but we saw a bunch of things like recommendation systems begin to work. Working on data sets like movie recommenders. And now, of course, we use them every day for product recommendation. So it's really a creative and wonderful phase in the evolution of machine learning. And then in around 2010, neural networks came back. And what that means is that the techniques that had sort of fizzled out a decade earlier actually became useful for two reasons. One is the volume of data that was necessary to train them exceeded the data available in the year 2000, but by 2010 was actually achievable at a cost that was reasonable. And the second is the twin of that. So that's memory and storage and data collection. The twin side of it is compute power, where we actually started to have affordable and powerful enough machines to be able to actually run this code at a scale that allowed for really interesting results. And when I say neural networks, I'm not going to assume everyone here is deeply familiar with them. So I actually want to show you how they work. A lot of the time, neural networks or deep learning are marketed as the brain, but the way you should think about this is instead that it is inspired by the way we thought the brain worked in the middle of the last century. So it is not a human brain by any means. What it is actually some simple algebra. And so this is a neuron. This is a diagram from work my group at Fast Forward Labs did a few years ago. On the input side, you have ones and zeros that are put into the neuron. You have weights, which are adjusted through the training process. You have a sum and a bias, but a sum in this case is just adding things up and then maybe adding or subtracting something from that number. An activation function, here it's just an if statement. So if the sum from the previous step is greater than 0.5, you output a 1. If it's not greater than 0.5, presumably you output a 0. And so this is just algebra, zeros and ones in, a zero or a one out. And deep learning just implies layers of these networks. And when you train them, you show them examples of classified input, and then you go back and tweak the weights, and you can tweak these other functions as well. And that's all we're talking about. So if you've ever felt at all intimidated by neural networks or deep learning, now you know what we're talking about. It's possible to do this with a little bit of algebra and some fun network architecture. And believe it or not, this has been transformative in a class of problems in computer vision first, that is image object recognition. So being able to say that's a photo of a puppy and a can of soda. And now transformative in narrative algorithms. And that's what I want to get into a little bit more. So natural language processing used for products in 2020. So let's think about where we actually apply this stuff. The problems we're interested in have changed dramatically. So we've shifted away from a focus on machine translation. And in fact, I would consider machine translation a 99% solved problem. Google has perhaps the largest trained neural network language model in the world applied to translation. If you haven't been paying attention, the quality has improved dramatically over the last couple of years. You used to be able to play games with it, like translate the same sentence to French and back, say, and you would get some sort of, almost like a game of telephone noise. Today, the quality is tremendous, and where it falls down is in colloquialisms, emerging language, dialects, areas where perhaps we do need to do some work, but it works pretty well. You could also make the claim that systems today could notably pass the Turing test. You have chatbots that are capable of stringing together coherent sentences as long as you don't care that they're nonsense. And we're now interested in problems around classification of text, around generation of text, of manipulation of text to, say, summarization, and around memory and attention in those domains. And again, I think we could say we've safely moved from a world in which we were interested primarily in translating from one human language to another, to one where we're interested in language as an input or output from a complex computational system. And so I like to think that the North Star, if you will, of our field has shifted, and the next few years are going to be really interesting. Now, if we go back to 2014, here's some work from my team at Fast Forward Labs at the time, where we built a real estate advertisement generator. So this was built by crawling, I think it was around 60 or 70,000 New York City real estate ads. You put in the structured data about the property you want, and then it will output language to describe that property. The approaches were pretty discrete. So here you have your raw data, you have a process you run where you decide what about the raw data is worth sharing. In this example, it's a weather report. And you then plan how to express that raw data in language. And then you assemble the language into a set of utterances that is hopefully relatively coherent. And then you may have another scoring function that scores potentially thousands of paragraphs to see which the best one is. That was the state-of-the-art approach in 2014. In just a moment, we'll come back to what it is today. Another area that has changed a lot is summarization. So this is the ability to take an article, reduce it to sentences, which are now represented as vectors, and then on the left, you have using extractive summarization, a set of sentences that represent the content of the entire article. And then the entire article is highlighted as well with the things you would have to read. This is again, this is 4 years old. Now we can do both extractive summarization, which is this sort of annotation and analysis, as well as abstractive summarization, which is generating new language that represents the same information here. And so just to say this again, because I want to make sure I say it very clear, what we're doing is modeling language. So we're able to take a document and represent it in a vector space that has the ability to be computed on mathematically. That means that we can take a word like New York City, and you could add music, and maybe you'd get Nashville out the other side. Because you would be able to see the relationships between those concepts in this vector space. And this is a really powerful tool that we're just starting to make use of. Meanwhile, if you work in this space, you've probably gotten excited about OpenAI's work on something called GPT-3. This uses a newer approach. Yes, I have it on the slide. There's a 2017 research paper you can take a look at called Attention is All You Need. It is a wonderful paper. There's actually a new one they just published on GPT-3, which is a refinement of this approach that uses essentially the same architecture. This is a transformer model architecture. We're not going to get into all the details of it, but essentially it is a layered neural network with feedback mechanisms using something called attention to allow you to build a more complex model of language. And they put essentially all of the internet plus a bunch of books, plus all of the internet in English, plus a bunch of books, plus as many news articles as can be found, and a small amount of non-English language content into this system, create a compact representation of it, and then you can use it for a variety of tasks. And I went ahead and had GPT-3 generate descriptions of Nashville to share with you. And so the bold text here, Nashville is most famous for, I wrote. And then I asked OpenAI's GPT-3 system to continue the sentence for me. So the rest of these sentences were all written by machine. And I did it 3 times in a row. I have not edited it at all. I actually am not super familiar with Nashville, so you all will have to tell me if this makes sense, if it makes you angry, if it makes you, feel like you missed the point. So I did one for Brooklyn just so I could feel like I was understanding the quality we were getting. And I feel like it very much misses the point. The Brooklyn Bridge is wonderful, but it leaves out all of the bagels and pizza, which, as far as I'm concerned, are the most important things about New York City. But this is a transformational capability for a couple of reasons. So one is that it's coherent. The second is that it may or may not be accurate. So these systems by design will actually hallucinate, and that is the technical term, things about, if they don't know what the continuation is, they're predicting the next token and the next, so they'll just sort of make stuff up. It's not creative. It is in fact aspiring to the average of the internet, which again leads to the third issue, which I'll get to a bit later too, which is that it can often be deeply problematic, if not useless, because the internet is not always the warmest, fuzziest, and most loving community to draw from. But that's pretty fun. What I think is actually remarkable about this from a language learning point of view is that it takes a few shot learning approach. So here I have a screenshot of me creating a system that does English to Dutch translation. And all I had to do was show it a few examples of the task I wanted to complete. So I put in the first 3 with the help of Duolingo and Google Translate, and then it was able to create the last sentence. It learned from my examples that I wanted a Dutch output, and it was able to do this. And so I'm not assuming that everyone here is deeply familiar with GPT-3 or has been following it online, but if you are, the thing that I'm most excited about with respect to it is not the token prediction, that works at all. We could already do that with earlier systems, and we could do it more reliably. But the fact that you can show it a few examples of a language task and it can mimic that. And this is not new. I actually first saw this from Rodney Brooks, who was the founder of iRobot that makes the Roombas, and then he started another company making an industrial robot called Baxter. You could put it on a production line, move its arms around and show it a task, and then it could do that task on the production line. And this few-shot learning approach, I think, is really amazing because it allows us to very rapidly play with new language tasks. I didn't put it in the slide, but I also made a converter from English to SQL. I should say it was very poor quality SQL, but it did more or less work. And so those are the sorts of tasks that we could have built a custom system for before. We might not have done it. Now we can play with it. I think you'll see that be really exciting in the next few years. And if that's not enough to be excited about, MC Hammer is on Twitter, you know, getting into debates with machine learning professors about GPT-3 and its potential. So that's the can't touch this guy. So I know it has to be cool, at least to somebody, if MC Hammer's in on it. I just find this very surreal that we live in a world where rappers also have opinions on narrative language systems, and awesome ones. So what is this useful for? Let's switch to thinking about the product side. A lot of things. So you'll see Siri, Alexa, Google Home, again, your spam filter, predictions of anything where language we've seen it before. So weather and financial news reporting being the two core examples. Predictive texting is a big one, translation, all of this fun stuff. And yes, there is an AI-enabled toothbrush if you want to go look that up. It will give you insights about your toothbrushing. I haven't been brave enough to get one yet. But the reason I wanted to pivot here to the product side is that all of these machine learning capabilities are exciting and interesting, but on their own, they are toys. Where we actually start to see value and where we actually start to see them have impact is when we're able to build them into real functional products. I spend most of my career thinking about how to build AI, machine learning, and data products. And right now I'm focused on how to build products around these narrative algorithms such that people can actually use them. And I wanted to share some principles of product design with respect to machine learning broadly, and then specifically with respect to narrative algorithms. Because this is an area where the interplay of that user experience and the technology can create something amazing that feels like magic. But if you're missing one side of it or the other, it just won't work. And I also think that having been a software engineer and spent a long time in building deterministic software systems, the way we think about product design around probabilistic systems is actually quite different. As software engineers, we think deeply about, we know what we're building is possible when we sit down to build it. We know we're more or less building it up as we go. With probabilistic systems, we don't know if it's possible. We don't know how we'll do it. We don't know the accuracy. We need to design the UX around the things we can actually solve versus the things we can't. And you will often find yourself starting with one machine learning or NLP problem to solve, and then realizing actually you need to solve an adjacent problem, and actually you need to solve an adjacent problem to that. And the process of building is as much research, try something, try again, and then design your user experience around accommodating the gaps in what your system is capable of. So let's talk about that. Yes, principles of building machine learning products. As I said, you want it to feel like magic, but you need to know there is no magic. All of these are computational systems. Data goes in, a model or representation is built, something comes out the other side. Everyone here in this call is capable of understanding how that works. And always keep in mind that if you can't imagine how such a system could function, it might not be possible. And if somebody says they have found one, you should be a little bit skeptical. Second, keep people first. That is the humans who are using the product, your players, your users, your customers. There is a class of machine learning and narrative systems that are built to replace human beings. In my experience, that's maybe 2 to 5% of production systems, and it is a very different kind of product design. the majority of these systems and where most of the value is to be found is in enhancing what people can do with information presented to them in a way that they can take action on. And that requires really putting your people at the front of every design process. Right. And you can't buy your way out of this. So you cannot just get this as an API. There are a subset of tasks you can buy your way out of. Those are the tasks where you are not the owner of the best data set for the task. And so these are things like speech to text, image recognition, if the thing you're recognizing are common objects, not if you're recognizing things like, particular medical issues. So there are a set of things that can be commoditized. You can buy those, but those are usually only a piece of what you're building. And I like to call this the data product gap, because it means that for a vendor to sell you a solution, they have to solve everybody's version of that problem, but you can actually just go build your thing. And in the narrative space, it's often an order of magnitude cheaper just to build it. So you should not give up because you can't buy it. Again, it's a core philosophy, augment what people can do in the system. Don't think I'm going to replace those, cashiers or those salespeople. It won't work. If you're having trouble inside an organization, think about investing to support something people are already doing that's already very expensive and reduce the cost of it. And then you get permission to build new things. And if you need a detailed framework, I wrote an article about this, but generally it's thinking about the dimensions of prioritization and how each thing you build allows you to build on top of it. So nothing is independent in data science and NLP. Everything builds on top of each other. And if you just need a framework for thinking through this stuff yourself, generally think, can a human do it? Can a group of humans do it with inter-rater reliability? And what that means is that you'll see systems where this is not the case and they don't work very well. Two areas where you may see that in narrative algorithms are sentiment analysis. So if we don't all agree amongst each other as educated human beings that something is a positive or a negative statement, how can a classifier do it? And you'll see the same thing with humor as well. Humor is one of the hardest problems in narrative algorithms. Computers cannot tell or understand jokes. Look for good narrative feedback loops. So if your system might make mistakes, try to get your people to correct those mistakes and then make your system better over time. And make sure that you're not just shoving this into an agile development process or a waterfall process where that's where probabilistic systems and narrative algorithms go to die. So make sure you know what problem you're trying to solve, what error metrics you care about, where it will be used and by whom, and then how it will be maintained, deployed, where those feedback loops fit in. And then finally, the dirty secret to building products with this stuff is to understand you're going to try to do one thing, realize you can't quite do it the way you thought, solve a narrower problem, realize you can't quite do that the way you thought, and so on and so on. And such, that means user experience is actually 90% of the solution. That is, people will forgive you if you design your product well around the flaws in your algorithm. And I'll give you another example of someone who does this very well. I use the Google Photos app. They are using image recognition on every photo to figure out what's in it, but they don't expose those labels to you because they're often wrong. But if you do go to search and you say something like beach ball, it will find all the things it thinks are a beach ball. And you're very forgiving if 1 in 10 photos that comes up is some guy's bald head instead of just beach balls. Because in the search metaphor, a little error doesn't matter. But if you were to label somebody's head as a beach ball, I would be laughing at you and think your product isn't very good. So there's lots of product design tricks here. All right, so while I maintain tons of enthusiasm for this, there are a few areas where we as a community need to focus. One, of course, is in ethics and accountability of these systems. And I'm going to give you an example of failure, again, from my own team's work, because that's the failure I'm allowed to talk about. So this is a system we built to take Instagram photos and classify what was in those photos for you and let you visualize the trends and what you like to take photos of or what other people take photos of. Here is Tourism Ireland. And I should say this was built about 4 years ago. So it's about 3 generations of technology behind. Um, so we found natural depressions, I guess that's valleys, bays and such, shops, yes, fortifications, rail fences, specific but very good. I love cheeseburgers, and so I put Bleecker Burger into this system, and it says, oh, and Bleecker Burger only takes pictures of burgers, except for one flag, which you'll see in the bottom right of the image. So one American flag, everything else is cheeseburgers. But for some reason, crabs popped up here. And when I went to look at that a little bit more deeply, I realized what had happened was that our image classifier essentially said anything that looked like French fries near water or near a dock was a crab. So it had been trained on something, presumably pokey things next to water or next to what appears to be a dock. The system had learned incorrectly in this case that it's a crab. Now, nobody taught it how to make that classification. Nobody taught it that pokey things next to water and wood are crabs. It inferred that from the data we showed it. And so hopefully this allows you to think through where failure can happen in the system very easily. Because you don't control the feature engineering, if you show it a biased data set, it will learn that bias. And even if you don't show it a biased data set, it will learn spurious correlations. And this is why with these systems, we need completely different kinds of testing, of accountability, of ways to debug, monitor, and manage them. And unfortunately today, most organizations and most people are not really mature in that practice because it is new. So if this is an area you're interested in working in, I really strongly encourage you to think about this from the beginning of the work. And again, we don't have time to go into detailed approaches, but I did co-author a book with DJ Patil, who was the chief data scientist under President Obama on this very topic. It's called Ethics in Data Science, and it is free. So if this is something you're interested in, I really encourage you to look that up as well. And there is also a Twitter fight going on today about Twitter's machine learning-based cropping algorithm privileging white people and privileging men over women as well. So if you're interested in wading into a live argument, that's a really interesting one to look at right now. Now, all of that is to say that this kind of issue is a problem because we're building something new. We are at a moment where the underlying technology has gained incredible capabilities, but we as a community are still figuring out how to build products around it, what those products will look like, what the experiences will be. And there is a ton of work still to do. So as I wrap this up, I would really strongly encourage you to play, to try to build things, to think about ways that narrative can influence the products that you're building and living with every day. And just to summarize, history is really important. In fact, if you want more reading on this, I was actually referring to this book to prepare for this talk, so it's still here on my desk. Computer science is not that old. So this is a book where Dennis Shasha and Kathy Lazaire went and interviewed a bunch of the foundational thinkers of the field, not strictly on machine learning or narrative algorithms, but there is a ton on early AI in here. It's called Out of Their Minds. I highly recommend it. Because history does really inform how we got where we are and why things are the way they are. We're seeing a bunch of step function changes in capability that are accelerated by linear changes, like changes in cost of GPUs and storage and memory. The fact that I can now download, tweak, and then upload a 1 gigabyte language vector model in about 5 lines of code means I can play and iterate way faster than even a year ago. It's really an exciting moment to be building this stuff. And to be building it for human beings. So if you take anything away at all, it's that humans first, machines make us better humans. I am building a company called Hidden Door, where we're building shared narrative worlds for kids using language generation to create dynamic experiences. So if you want to find out more about that, please join our mailing list. And that is it. So I think hopefully Dan will reappear and we can do some Q&A. And thank you all so much. I know these online conferences always take a little bit of extra energy and attention. So thank you for your time for participating.
Second. There we go. All right. See, it worked seamlessly. Hilary, thank you so much. That was perfect. Excellent presentation. I loved it. I'm a 90s kid myself. That's when I started coding. Not very well, of course, which is pretty much why I don't do it anymore. But I love the references. I love the stuff about kind of the rigor of engineering, but yet the creativity of having to use narrative algorithms. It's absolutely great. We do have a few questions to get us started, but I'm going to encourage everyone here to now kind of push those through, and we will kind of get those answered here over the next 15, 20 minutes or so. Are you ready?
I'm ready.
All right, let's see here. So I think the first one that came up was, what was the HBR article you'd flashed up? But I believe you might have already answered that.
So I flashed it up. I didn't choose the headline. So I think it was called something like How to Work on the Right Problems. But that article is one in which I shared the experience of every company I visited had generally a scatter plot of projects with cost to implement on one axis and value to company on the other. And they just sort of pick one quadrant. And that is completely a naive way to allocate your attention and investment in machine learning and data science products, because every bit of work you do to clean a data set, refine it, learn something about the domain should be something you can build on. And so that is the core idea of the article. And I think if you were to Google HBR, my name, and something like that, you will find it.
Excellent. So it looks like another one that's come up here. So in the past week, it would seem that the facial recognition algorithms that both Zoom and Twitter use to crop headshot thumbnails have bias toward white people. Do you, let's see, how do data science address these kind of biases in narrative algorithms? Good question.
Oh, it's such a good question. It is an active area of research. And so there are systems that are available both for image algorithm analysis and narrative algorithm analysis. And these are things like LIME or SHAP. And these are things where conceptually you have a range of inputs and you take the black box model, which might be a black box because it's a neural network and it's mathematically a black box, or it might be a black box because it's Twitter and they're not telling us how it works. You throw a bunch of things at it, you permute those inputs to explore space, you look at how the outputs change, and then you can use that to infer the significant features in the classification. It is a good way to look for bias, and it is something you should probably be doing to your own systems before you are putting them in production. That said, this is not a technical problem as much as it is one about, because well, there are technical tools you should be using, but don't think that technology itself will solve this without thinking deeply about the systems you're building, the impact it's having on people, how you deploy them, and then how you respond to community feedback. So Twitter did, after a day of controversy, make a statement that they had indeed tried testing their cropping algorithms and they had not seen any evidence of bias. They were going to go back and revisit that process. So the fact that they even tried was good. There's another interesting thread that came out in the discussion, which is that a lot of people, sort of said, well, they're not using facial recognition. Maybe they are, maybe they're not, we don't know. So it can't be that biased, but my intuition here is that even if they're using something like the lightest, average pixel value or the biggest contrast in pixel value, right, even if that's the algorithm, if the impact is to be discriminatory, they need to know that. And I say that as an extremely pale person, like they really need to be testing for that and working on it. And once evidence is found, and one of the interesting things about the Twitter issue is people immediately started experimenting with it. I saw people throwing Simpsons characters in there to see what happened, throwing dogs, so like the white puppy versus the black puppy, seeing similar effects too.
This conjures up
Yeah,
that whole dress thing that came out a couple years ago. What color was the dress, right? Was
that's
it
right.
dark blue? Was it gold?
Right. That was a human perception, right?
Right.
Yeah, so I think that, you know, if you're working on a system like this, you need to have some of those testing pieces in place, and then very quickly have a mechanism to honestly respond to feedback. What worries me more, the number of machine learning systems that don't have, where a like a consumer impacted by them has no input into the spectrum of classifications, and therefore can't highlight that bias. And that's where you
Right.
have to be particularly careful.
Excellent. Looks like our next question here. Do you think there's a place today for retro AI, like rules-based, hand-coded expert systems?
Is there a place for it? Absolutely. And in fact, I am a big fan. When I build these systems, I don't start with neural networks. I build the simplest possible thing that will suffice with an end-to-end pipeline. So data in, something in place, even if it's just some hand-coded something out the other side, and then wait for that to fail from a product point of view before going back to replace it with something more complex. I also think that we've seen many classic themes of AI reemerge. So I personally am waiting for genetic algorithms to get their day in the limelight. It's the kind of thing used in production for only one thing, as far as I know, maybe two, and that happens to be antenna design. I feel like we are, you know, at the edge of that coming back. Same thing for reinforcement learning. So yes, I think there's a place for expert systems, and, you know, building those extremely transparent systems in your development process. And then also, I think a lot of the ideas that, you know, were sort of put on the shelf back in the 90s or early 2000s are likely to reemerge too.
Absolutely. And there's, you know, even like in music, there's always a time and a place for, you know, pulling out your old LPs and listening to that. So next one on here, I just watched Social Dilemma on Netflix. What kind of responsibility should us humans have on the engineering of NLP and machine learning? Where should companies step in to assure data science is not inhumane, especially in a healthcare space?
So I have not watched Social Dilemma yet.
I actually haven't either.
Yeah, so please take my comments with the lack of context. But I do, so I worked on social media starting in 2008, 2009. I was at a company called Bitly, which is a social media analytics tool that still pops up now and again with short URLs. It was built into Twitter, but it crossed pretty much anywhere people were being social at that time. It was a very large volume of data for the time as well, and it was fascinating. We had no idea what could be done with that data. And we had no idea, frankly, what power these systems would have. So that's the perspective I speak with, which is to say that some form of transparency is probably, and that is likely to come from a regulatory framework, is likely the best way to address these systems. And just to understand that any tiny bit of bias or issue at scale, even if it's a tiny problem, becomes a huge problem. And this is to think about things like, if you think about machine learning in a hiring process, you will probably encounter a sexist or racist or ageist hiring manager in your career. And by you, I mean all of us. If it's just the one and you can find another one who is not, who is happy to work with you and your talents, then great, you're fine. But if everyone is using the same tool and that bias is propagated across that tool, then it becomes a huge systematic problem, even if it is a tiny amount of bias. And we see the same thing in the algorithms used to control information and misinformation right now. Yeah. And I don't have an easy answer, but I think this is one of the most fundamental philosophical challenges in front of us. And that, absolutely. Yes, we have a lot of work to do to build systems to introspect into those algorithms as well.
I agree. We have another one here. So it's, and I happen to have interest in this one too. So you mentioned that machine translation is a solved problem, but there are many low resource languages that have been ignored by NLP community. Any thoughts on how these or those languages may be included in the future?
Yeah, so I believe I said it was something like a 99% solved problem because there are still many of these little corners that are really interesting. And so, yeah, our fundamental, so language translation used to require a paired corpus. So you used to have the same language in, or the same text, same meaning in language A and in language B, and then you could build some kind of model from that. And there are a few famous corpuses that were used, like the Europarl, the European Parliament minutes, which are in something like 7 or 8 languages. And you saw a huge bias in coverage to where the data was available. This questioner obviously knows what they're talking about, because now the challenge is for languages where you not just don't have a paired corpus, you don't even have enough language data to build an independent model. There was some really interesting work last year, I believe it was a Facebook group, in being able to take any language or any data in a given language to build a vector-based model of it, and then connect that to other vector-based models of languages to create translations. And I think that's probably the most promising direction, but it still requires an extremely large amount of data, which may or may not exist for some of these languages. And so you do see gaps. And then you also see additional problems like the ones I think I mentioned around colloquialisms, evolving language, accents.
Right, my favorite one, I think actually came from I think I hate to say it's like an insurance car company commercial. And it was, what one phrase means positive and negative, and it was, yeah, sure. It's like, oh yeah, sure, or yeah, sure. I love that one. And it was because you have to have the context of what happens to understand what that means. All right, the next one on here is AI ML can create superheroes, but can also create supervillains, hopefully by accident. Would you support regulatory oversight on how we create and explore these new technologies to reduce the supervillains?
So I do, though I am generally a fan of regulation where it pushes towards transparency and consumer control of data and the inferences from that data. I am not so much a fan of regulation that by name prohibits certain people or certain, say, mathematical techniques from being used in systems. And so, and again, this is just my opinion. I am not a lawyer, I am a computer scientist. That's generally where I think we will see the most benefit to prohibit or at least recognize those villains. I think the problem now is not so much that they're out there blowing things up, but rather that they're out there and we don't even know it.
Right. Very much so. Great aim. Let's see our next one on here. Hilary, during your talk, you mentioned a space within the broader world of AI and ML that has overpromised and underdelivered. From your intuition judgment, what helps you identify when that is occurring?
Oh man, that's a great question. So AI as a field has a rich history of overpromising and underdelivering. If you go back to the 50s and 60s, they thought language translation would be a solved problem in 10 years. They thought intelligent machines would exist by now. We don't have these things, and what it's caused are these cycles of overinvestment and then sort of a lack of investment. So there was an AI crash in the late 80s, early 90s. Nobody wanted to do it anymore. Nobody wanted to fund it. That's part of why I believe the community started calling it machine learning. There was also a new set of techniques around statistical inference. So there was a rebranding. I think we are at hopefully the peak of another sort of, let's say, AI overpromising. We've seen a few subwaves of it over the last few years. So we saw For example, everyone very excited about chatbots in 2016, 2017, but their promise wasn't really realized because the technology wasn't there yet. We see the same thing with AI in general right now. I spent a lot of time in the last few years thinking about how we can shift the conversation away from AI to the actual utility of the AI system. So like, let's not get excited about it because of the type of mathematics. Let's get excited about it because it's useful. And I think we have a ways to go with that. So we are likely, we're likely going to see a lot of that in the next year or so anyway.
Excellent. Yeah, thank you. Let's see the next one on here. So thanks for the great talk. Do you have any advice for protecting against machine learning products being applied to areas it was never designed for? I believe there was an example where a model used to predict, well, I knew there was going to be one word in here that I couldn't pronounce. Recidivism was used during trials, and apologies if I mispronounced that.
Yeah, so this is in reference, I believe ProPublica did a bunch of work on this commercial model for recidivism, which it turned out was quite racially biased. Yeah, so this is an area where governance of where AI systems are used in a process is vitally important. We saw a similar type of thing happen actually in the UK. The final schooling grades were inferred by machine because kids couldn't sit for their exams. And it turned out that, you know, the wealth of the community you came from was a significant feature in the grade you got. Now, of course, that's horrific, right? Like, this is an area where we need broad governance of why you should even be using a probabilistic system at all. And frankly, this is not a technology problem. This is a society policy problem. Technology in the tech community does make it worse by overselling what these systems are capable of. But it is also important to keep in mind always that while these systems are fantastic at making predictions across a population, the predictions they will make in any individual case are extremely likely to be wrong. And this is one of those counterintuitive things folks really need to keep in mind where they're thinking about whether it's appropriate to use such a system at all. So I don't think there's a technology solution to this. I think we go back to, you know, regulatory governance to even, you know, some kind of direction about where it makes sense to use these systems and where it doesn't. And like clearly in both of these cases are so egregious. I mean, in the first case, somebody is getting paid and people will build whatever they can get paid for, and that is unethical. In the latter, you know, I'm not sure where the bad idea came from.
Yeah, it's tough to say, but definitely agree on that. But I think that segues into, and I'm going to paraphrase this kind of next question is, as technologists and people, you know, kind of in a field and a discipline that is sometimes hard to explain to the general business person, whether it's a business leader or even a manager within a, you know, an adjoining function, how do you, you know, begin to kind of explain? Obviously, you used some great examples earlier today, you know, referencing the beach ball, and I've even seen stuff where people they relate olives to people's bald heads. Unfortunately, two different bald heads examples here, but how do you best relate some of the work that you do back to business owners as you explain, you know, kind of what you just mentioned, the opportunistic side of being able to use this for decisions, faster decisions, but then the very real negative downfalls of doing bad with it?
Yeah, I mean, unfortunately, we're doing this in a context of sort of proud numeracy as well. I remember when I was a computer science professor, I was on this committee where one of the English professors once was like, well, I don't do math. Math is hard. It's just like, what do you mean? You can't say that as a, you know, professional. Like, what if I just said, I don't do words? Words are hard. And like, no, of course not. They are hard, and math can be hard, but it's still, you know, we live in this backdrop of, and especially in organizations today, many leaders and executives don't feel like it's their ability or responsibility to understand how these systems work. And because these systems are different and they can be complex, it is often a challenge. And you're coming at it when you have a legacy of a development process that has actually worked pretty well so far. And this can be, like, I've seen these issues in groups that come from a software engineering point of view. I see these issues in groups that come from a more traditional CIO IT point of view, which is where the, like, I'm gonna buy my way out of this idea tends to come from. And then I see it also from folks who are coming from a more, let's say, CEO sales driven point of view, where it's, you know, I want linearly predicted, you know, I want predicted growth, predicted revenue that I can actually, you know, rely on. I don't want you to say this might work or this might not work.
Right, I want a graph that goes up and to the right.
Yeah, always that. And so the challenge then for the technologist in this space is to, like, it's hard. Like, I actually think most companies do a terrible job of this. And it's not because people aren't smart and well-intentioned and want to work together. It's because the organization design is set up against doing this well. Where people think their responsibilities are is set up against this. And then you come in and you don't have control, you don't have power. And so you're trying to influence people to really understand what goes in, what happens, what comes out the other side, and where this is potentially useful and where it's potentially dangerous. And unfortunately, that is really hard.
Yes.
So I don't have any easy answers other than just to share that in organizations where the top leadership gets this, you will get there. It will take time and there will be change and there will be some pain along the way. In organizations where you lack that leadership appreciation, you will likely be ramming your head against the wall. So that's my experience.
All right. Well, thank you very much. Unfortunately, that is all the time we have today. But Hilary, you know, on behalf of the Greater National Technology Council and the rest of everyone here at the Analytics Summit, we really appreciate you joining us today. It was excellent. I can say on behalf of everyone here, a big round of applause, even though obviously we're not getting that these days, but I really do appreciate your time. And please, everyone sees Hilary's contact information here. If you have questions, feel free to reach out. Hilary, any last words you want to say?
I just want to say those were the best questions I've gotten at a presentation in
such
a long time. So thank you. I
job,
really regret that this is not a live discussion. Thank you, everyone.
Maybe next year.
Yes.
Excellent. All right. Well, join us again later today for happy hour and the rest of our presentation. Thank you again, Hilary, and we'll see you all soon.